Before showing how to work with IPv6, I'd like to talk about it a little bit. IPv6 is the new generation of IP addressing for the internet, but it can also be used on internal business networks or home networks. It was designed to meet the limitations of IP version 4, including address space and security. For example, IP version 4 is a 32-bit system, meaning that its address space is limited to 4 billion values. IP version 6 is a 128-bit system, which allows for 340 undecillion addresses. IP version 4 has less security in general, and for example, IP version 6, IPsec is mandatory. IP version 6 also has a different packet format which minimizes packet header processing. So IP version 6 is a more advanced new generation of Internet protocol. Installing and testing IP version 6. IPv6 is installed by adding a component to your network adapter. Let's show a demonstration of this now. We want to go to the Network Connections window and go to one of the adapters, for example, a local area connection. We'll right-click and go to Properties, and that'll bring up the Local Area Connection Properties window. Then we'll go to the Install button, which will give us some options. We want to select Protocol and Add. From there, the first option that we see is Microsoft TCP/IP version 6. So we'll click OK for that, and that's going to go ahead through the installation and bind that not only to the local area connection, but also to the wireless network connection and any other types of connections that you might have. Okay, and now it's installed. We'll go ahead and click Close, and that'll complete the installation. So a very simple installation of IP version 6. Now, IP version 6 addresses are auto-configured in Windows by default and are known as link local addresses. They can be viewed with the ipconfig command that we've used in previous labs. Let's show a demonstration of that now. If we go to the command line and run an ipconfig/all, we'll get the information about our network adapters. For example, our local area connection. Here's our original IP address, our IP version 4 address, and here is the IP version 6 address. When you see lots of numbers written in hexadecimal separated by colons, you know it's an IP version 6 address. And I know this is a link local address because it starts with FE80. To test whether the IP version 6 address works, you can use the ping command. And to show a demonstration of this, I'm going to go to the server computer. Okay, we're at the server computer, and I've already installed IP version 6, and an IP address has self-assigned to the system. Now, there's several types of pings we can do. The first is pinging the local loopback address, which in IP version 6 is ::1. When we do so, we get replies from that address. This is the equivalent of IP version 4, 127.0.0.1. And every computer that's running IP version 6 has this address, ::1. Next, we can ping logical IP addresses on any system. For example, FE80, ::260, :8FF, FEC0, :98D, %4. And we get replies from that address. And we know that is a link local address that's been self-assigned by IP version 6. You can also ping by host name, but usually you need to do so with the -6 parameter. So if we do a ping, we'll add -6, and an example of a host name is 2003 DC. When we do so, that gets replies from the IP version 6 address. Finally, we can ping IP version 6 addresses that have an IP version 4 address encapsulated within them. An example of this would be ping FE80, ::5EFE, and the IP version 4 section, 10.0.0.4, and in this case it's %2, and that's another laptop on the network. And we get replies from that IP version 6 address that has the IP version 4 address encapsulated within it. We'll go back to the laptop now and we'll run a ping to Google. To do so, we'll ping the IP version 6 address within google.com, and we're going to do that by doing a ping with the -6 because we're going to be pinging a host name, IPv6.google.com. And when we press enter, it resolves the address, and you can see the IP version 6 address. It starts with 2001, but I'm getting the message destination host unreachable, and that's for two reasons. One, because I'm using a link local address on this computer, and it's not meant to be routed outside my network. And two, because my ISP won't let these packets through at this time. They're not currently assigning IP version 6 addresses. It speaks to the fact that there is less than 1% penetration of IP version 6 in the USA at this time. However, this number will quickly grow over the next few years, and some analysts have projected that we'll run out of IP version 4 addresses by 2012. So you can expect to see more IP version 6 networks and hybrid IP version 6 and IP version 4 networks in the near future. Let's take it to the next level by adding addresses with the netsh command. You can add IP version 6 or IP version 4 addresses by using the network shell in the command line. Now first I want to go to my network connections and change the name of my network adapter. Its current name, local area connection, has spaces in it. And just to make it easier, I'm going to rename that to LAN, so it'll be easier to type in the command line. And by the way, spaces don't fare very well in the command line or in networking in general for that matter. So we give it a new name, and we'll go to the command line now and we'll type netsh, which is the network shell command. Now we need to tell the computer what we're trying to do. What I want to do is I want to add a new IP version 6 address to my network adapter, which is also known as an interface. So the syntax is netsh space interface space IPv6 space add space address space interface equals, and the name of the interface, which I just renamed to LAN, space address equals, and we'll type in the entire IP version 6 address now. So that's going to be 2001 colon 4860 colon 0000 colon 2001 colon 0000 colon 0000 colon 0000 colon 0068. We'll press enter, and that'll say OK, and that's bound the new IP version 6 address to that LAN interface. And this is actually a global unicast address. You may recognize it from when we pinged Google. This is just an example. I'm just showing how to add an address. So to see this, we'll do a quick ipconfig, and we'll see the new information. Here's the new address that I just added. It shows it in a truncated format, and we'll talk more about truncating in a little bit. Here's the original IP version 6 address for this computer. Now, if you want to remove the address, you can do so by typing the same syntax, but instead of add, you would just use the delete option. And if we press enter, it says OK. And if we run an ipconfig again, we'll see that that address has been removed. Okay, good job so far. I want to talk a little bit more about IP version 6 addresses. IPv6 addresses are 128-bit hexadecimal numbers divided into 8 groups of 4 numbers each. And here's an example. In fact, this is the address we added to our computer. Of course, these addresses will commonly have letters in them as well, since they're hexadecimal. It just so happens that this address does not. Now, here's the same address in a truncated format. And there's two different ways that we can truncate the address. The first is if you see a whole group of zeros. We can take a whole group of zeros, here we have 12 zeros, and we can abbreviate that down to a double colon. But they have to be consecutive zeros. And if you're doing that with more than 4 zeros, you can only do it once in an IPv6 address. However, if there's 4 zeros or less, you can truncate those as well. For example, these 4 zeros have been truncated down to 1 zero. So two possible ways to truncate or abbreviate the IP version 6 address so it's a little bit easier to manage. This particular address is known as a global unicast address. It's a publicly routable address, much like a standard public IP version 4 address. Let's dissect a global unicast address. We break it down into three sections. The first is the global routing prefix, 2001:4860:0000. The second section is the subnet, in this case 2001, and then the individual interface ID, 12 zeros, another 2 zeros, and 6 8. So it's some IP dissection for you. Finally, let's talk types of IPv6 addresses. The first is unicast. These define a single address on a single network interface. One type is global unicast. This is a publicly displayed address that is routable on the internet. And the address range for this starts with 2000. The other type is link local. And these are the loopback and auto-configured addresses we've previously shown. The loopback address is ::1, or automatically configured addresses will start at the FE80 range. Next is Anycast. Anycast addresses are assigned to a group of interfaces, most likely on separate hosts. Packets sent to this address are delivered to only one of the interfaces, the first one available, usually the closest one, so to speak. This works well for failover systems and for load balancing. And we have multicast. Multicast addresses are assigned to a group of interfaces as well, like Anycast addresses. And also, these interfaces are most likely on separate hosts. However, packets sent to this address will be delivered to all interfaces in the group. These are similar to older IPv4 broadcast addresses. However, multicast addresses do not suffer from broadcast storms the way IPv4 addresses do. IPv6 ranges. The IANA has assigned specific ranges for unicast and multicast addresses. Here's an example. The link local range is FE80::/10. This means that we can use any address that starts with FE80, FE90, FEA0, and FEB0. That's a considerable amount of addresses. It's far more than the entire IPv4 system can handle. And that's only 1/1000th of the entire IPv6 system. Let's take one last look at ipconfig. And this time I'm going to do an ipconfig/all, and we'll take a look at our information. Here's the link local address that's been auto-assigned by the operating system. As you can see, it starts with FE80. Now, a question I get quite often from students is, what's the Teredo tunneling pseudo interface? What is this thing? What is this automatic tunneling pseudo interface? Well, Teredo is a protocol that encapsulates IPv6 packets inside of IPv4 datagrams. This allows IPv6 connectivity for hosts that are behind an IPv4 device. This would be known as an IPv6 unaware device. And this happens. A lot of networks are behind firewalls or multifunction devices that are not aware or programmed for IPv6. And so you have this encapsulation going on, IPv4 inside of IPv6, like that address that we pinged before, which had that class A 10.0.0.4 address inside of the IPv6 address. That was actually a tunnel adapter, automatic tunneling pseudo interface that we were pinging before. So that's what your Teredo tunneling pseudo interface does for you. Okay, in this lab we described IPv6, we installed Microsoft TCP/IP version 6, and by the way, it installs the same way to a Windows client as it does on a Windows server. We verified and tested IPv6 addresses with ipconfig and with ping. We identified the various types of IPv6 addresses, and also we added an address with the netsh command. Up next is Lab 5, Configuring DHCP.